end date is the earliest of the date of reaching age X plus 1. Dekat situ meaning hari after birthday, like one day after birthday or hari birthday tu.
Sorry, kejap. You punya suara putus-putus lah, I tak dengar. Tak tahu I putus ke you putus, tapi I tak dengar soalan you. Sekali lagi.
Dekat yang slide exact calculation of exposed to risk, dekat situ ada the end date is the earliest of the date of reaching age X plus 1. Dekat situ meaning after birthday, meaning like one day after birthday or hari birthday tu. Yang X plus 1.
Oh, the year. Dia X plus 1 tu year lah. Kata age dia is 65, currently age 65. Kalau X plus 1 which mean dia age 66. Dia bukan one day, dia kira a year.
Oh, maksudnya hari birthday tu lah kan?
Dia assume tambah satu lah.
Kan? Dia assume tambah satu macam age next birthday, age last birthday kan? Itu after
Adam, suara putus-putus.
Suara Madam terputus-putus.
Kelas age nearest birthday. Okay, kita akan belajar 3 tu lah.
Sorry Madam,
suara Madam.
Madam putus-putus.
Okey, boleh dengar tak sekarang? Tak dengar guys? Tak dengar
Sekarang boleh.
Dengar.
Sekarang boleh.
Okey. Alright, kalau you tak dengar, you message lah sebab I punya rumah ni kadang internet dia down sikit. Okay, so maksudnya kalau age next birthday, age nearest birthday or age last birthday, kita akan age tu, current age is X. Okay, so nanti bila kita belajar next birthday or last birthday, benda tu kita akan X plus 1, X minus 1. Okay, which mean dia kena kira dia punya year lah. Kalau maksudnya kalau currently age 65, kalau X plus 1 is 66. Kalau X minus 1 is 64. Okay, boleh dengar tak?
Boleh. Faham.
Okay. Yang itulah, dia bukan day, dia kira year. Sebab age kan. Kalau you kira day, nanti dia ada juga yang kira day. Tapi kalau kira day ni, you kena divide by 365 days lah. Nanti age dia jadi, kalau one day nanti jadilah 65 point something. Yang itu dah macam actual mathematics nanti. Okay? Ada any other questions?
Madam, saya nak tanya. Okay, yang trapezial assumption tu memang base dia akan jadi satu ataupun dia boleh jadi any nilai?
Dia boleh jadi half. Ini I nak discuss after this. I nak bagi examples on trapeziums.
Okay, baik.
Okay, any other questions before I nak bagi examples lain lah. Ada tak? Tak ada yang lain? So I boleh proceed Sekejap, I buka slide. Okay, so if kita dah discuss kat sini on center exposed to risk, all age for this population lah, ada population yang I akan kasih ni lah. Alright, so kita assume okay, katalah examples. Examples, okay. Numbers of population. Boleh nampak slide you guys?
Boleh, Madam.
Boleh.
1000, okay, equals to 10,000. Okay, this is population Nanti next class kita akan belajar, kita kira each individual punya exposed to risk. Yang ni kita belajar on the populations, right? So P 2001, right? So equals to 30,000. Okay, P2002 equals to kita assume 20,000 lah. Okay. Then P2003 kita assume 40k. Alright, so katalah kita nak kira central exposed to risk. Okay, kita guna central exposed to risk lah. Kan? Okay, you ada tadi formula you tengok dalam slide tu ada half plus PX then plus PX plus 1. Okay, so now kita given you the numbers of populations. Alright, so katalah period kita punya contributions punya periods tu is period cover. Okay, katalah kita assume 1st January 2000 until 31st 12 2001. Okay, yearly lah sebab kita nak kira year by year. Alright, so ini question number 1 lah. Okay, so sekarang kita nak cari exposed to risk for question number 1 lah. Okay, this is dia punya apa ni lah kita panggil contribution year, kita panggil apa? Astagfirullah, observation period. Okay, this is observation period. Okay, dia ada observation period dan nanti kita ada juga dia punya estimate punya intervals lah. Kita assume dulu observation period kita adalah 1 year lah. 2 years. Alright. So tadi kita tengok the formula is half. Okay, so now trapezium. Okay, kita divide into 2 because the 2 years kan. So this is year 2000, this is year 2001. So this is year 1st January 00, this is 1st January 01, this is 1st January 02. Okay. Alamak, tak muat je. Okay. So kita tengok kat sini dia kata period cover 1st January sampai 31st 12 2001. 31st 12 2001 kat sini lah. Betul kan? 01. Okay, dan dia sama juga dengan 1st January 2002. Alright, kalau you tengok you masuklah figures this one kalau 2000 dia 10k. Okay, kata let's assume 10k kat sini lah. Okay. Then dekat 1st January 2001 okay, dia punya numbers of population is 30k, kita assume kat sini. Alright, 2002 numbers of population is 20k, so 20k lebih kurang kat tengah-tengah ni lah. Okay, you boleh tengok kat sini dia macam trapezium lah. Ni first trapezium, this one the second trapezium. Okay, so you boleh letak kat sini. Sini 10k. This one is 30k. So dia tak straight line sangat. Alright, so this is okay. So macam mana kita nak cari exact exposure for this population lah. Sebab dia bagi the observation period is 1st January 2000 until 31st 12 2001, 2 years. Okay, so nah, so you kira macam trapezium juga. So equals to buka bracket A plus B tutup bracket. Kan? Macam trapezium macam you belajar kat SPM. Okay. So now A is sini lah. You kena tengok trapezium ni terbalik lah. Okay. So this is dia punya length lah. So 0 to 10k. So 10k. Okay lah. Okay. The length from 0 to 30k. So 30,000. Tutup bracket. Okay, 1 year. Dia punya tinggi ni is 1. Kira 1 year. Kalau dia half, then dia jadi half lah sini. Dia punya tinggi ni. Okay, kalau dia 3/4, then 3/4. Okay, so now you times by 1 lah. Okay, dalam formula tu tak ada lah tulis 1. Okay, so plus with the second trapezium is half 30k plus with 20K. 20,000. Okay, times by also 1 year. Okay, sebab kenapa kita tak buat 2 years, population year 1 year. Okay, population dia tak sama. That's why kita split 1 year 1 year. Alright, so setengah student ada tanya kenapa tak kita times by 2 je. Tak boleh. Okay, because population is different. Every year they have the different populations. Right, so nanti kita tambah. So this is 40 divided by 2 is 20,000. Plus 30 plus 20K equals to 50. 50 divided by 2 is 25,000. Then you will get 45,000. Okay, so this is yang simple lah. Alright, so if kita ada katakanlah dia punya period of cover tu nama tak ada. Sekejap I cuba I tambah page sekejap.
Madam.
Alright, so if
Tak apa, teruskan dulu.
tak apa, you nak terus sebelum ni boleh tanya. Kenapa?
Basically apa maksud central exposed to risk tu, EXC tu?
Exposure, kita kira exposure.
Oh,
Dia macam exposure macam kita yang this slide ni kita discuss, kita only calculate the exposure. Why kita need to calculate the exposure? Because nanti kita nak cari estimate of QX. Okay, estimate of QX ni numbers maksud apa? Number of death divided by total. Maksud apa ya? Saya tak dengar lah.
Okay, maksudnya total policy yang enforce lah untuk betul macam tu.
Total number of policy. Kalau in terms of policy lah.
Okay, faham. Yang enforce lah kan?
Tapi exposure tu entah kalau you based on insurance lah. Okay tak guys? Dengar tak?
Okay, madam, okay.
Aduh, apa lain tulisan ni? Okay, so why kita nak cari total exposure? Because kita nanti kita nak calculate we need to find what is estimate of QX. Kita nak estimate QX. So when you want to estimate the QX, you kena tahu total number of death. Total number of death ni definitely you boleh tahulah. Okay, nanti given. Dan total exposure. This one yang kita kira total exposure ni. Macam dulu before this, you ada belajar juga dengan siapa? Dr. Shazrin. Dia ada guna maximum likelihood estimate kan? Macam ni jugalah. Okay. Tapi this is different kinds of method lah. Alright. So if B, kita tengok Okay. B kita punya observation period. Okay, equals to, kita assume 1st June 2001 until 30th kalau first ini sampai 30th lah. Okay. 2002. Okay, 1 year lah. Kita assume 1 year. Okay, kalau tak kita buat macam ni. Daripada Julai sampai sampai bulan 6. Okay. So now kalau if you tak boleh buat ni. Okay. Kita draw the timeline. Okay. Ada dua juga 2 years kan? Okay, this is 2001. This is 2002. Okay. So tadi kita tahu 2000, this is 1st January 2001. First the population is equals to 30K. So kita assume 30K kat sini lah. Okay. Okay, then 1st January 2002 is equals to 20k. Dia rendah sikit. Okay. Right, then masa 2003 1st January 03, okay, the population is 40k, so dia kat sini lah lebih kurang. Okay, so kita tengok kita punya observation period is from 1st July, so 1st July kat middle lah, kat sini lah kita assume. Okay, so kita kena tahu. Okay, so kita nak tahu, okay, from here daripada 1st January sampai 31st 12 2001, numbers of population dekat 1st July 2001 ni berapa? Okay, so we assume because this is the middles, so kita assume dia half lah, half from this one, and then dia reduce half. So 30 to 20, half is equals to 25k. Okay, macam you belajar dulu lah, dia punya mid lah, between 30k dengan 20k, the mid is 25k. Okay, so kat sini lah. Alright, since goes to the 30th June, so 30th June kat sini lah, lebih kurang middle juga. Alright, so you kena cari lah kat tengah-tengah ni berapa kat sini, lebih kurang. Okay, ni. Alright, so this one 20 dengan 30, middle is 30k. Okay, so now you can draw the okay, this one you go down. Okay, this is the first trapezium. This is the second trapezium. Length this one is half. This is also half. So now you can calculate the central exposed to risk is equals to half formula trapezium, yeah? So 25k times by half. Okay, plus second trapezium 20 plus with 30k times by half. Okay, but if the question cakap dia sampai end of 31st 12 2002, so you punya trapezium end kat sini lah. Second trapezium on the questions lah, tengok dia punya observation period tu. This is for if you want to find sense of all ages. Okay, kalau if for individual age, you kena tengok individual satu-satu. Okay, so this one, so don't forget the half ni lah. Most of the student dia lupa this half, dia punya tinggi ni. The length between half year ni, half year. Okay, so 35, that's why I divide lah, then you get the answers. Alright, so if, okay, so because this one kita assume this one, why kita guna trapezium ni, sebab kita assume dia follow apa ni lah, dia punya apa movement tu, population movement tu kita follow linear. Okay, that's why kita boleh buat straight line macam ni. Okay, kalau if they assume different distribution other than linear, so tak boleh lah, you cannot use this trapezium punya method lah. Okay, tapi for this one kita memang assume linear. Okay, so if the questions katakanlah the questions tu you ada sampai sini 40k, okay, then suddenly you don't have any information, katakanlah you want to find until dekat sini, saya sambung ya. So katakanlah dia nak cari katakanlah you nak cari kat sini, macam half of this year is sini adalah dia. numbers of population up to 1st January 2003. Lepas tu you tak ada, kat sini tak ada. 2004 you tak ada. Alright, so you can assume because this linear, you boleh assume dia punya population tak berubah. Constant. Kita assume constant. Okay, you boleh assume constant. Okay, bila constant ni dia dah jadi macam apa? Macam apa ni lah. Cuboid lah. Okay. Right, kita assume constant. Kalau kita ada information, that information for the other year atau a year before, kita ada information of the numbers of population, kita boleh assume constant. Okay. Tapi you tak boleh lah constant sampai 2005, tak boleh. Because dia only year by year lah. So you boleh assume the year tu only constant for the next year tu lah. Okay, dia tak ada movement lah for the population tu. Alright. Okay, do you have any other questions regarding this trapezium ni? Sebab last semester ramai yang tak boleh nak buat trapezium. Clear tak? Saya takut line I tak clear.
Clear, madam.
Clear, madam.
Okay, so ada any other questions? Okay, so for trapezium untuk population, whole population ni bagi saya senang sikit lah. Compared to if, nanti kita later kita akan discuss on, sama juga kita nak cari exposure juga. Saya cari exposure risk atau initial exposure risk. Kita akan assume age next birthday dengan age last birthday, age nearest birthday. Yang tu dia tricky sikit lah. Okay, that one is next week punya kelas lah. Okay, if you don't have any questions, okay, sorry. So for next class yang offline, okay, maybe on Tuesday, I akan ada upload ini ada upload examples. Okay, examples for part 1 dalam Teams. You boleh download and bisa understand. You boleh tanya before class next week. Okay, next class online tu before kita ada Q&A tu, you boleh tanya soalan for example. Kita nak kira dia punya exposure je untuk individu. Kelas saya akan upload apa nama tu, slide for next yang next class punya apa ni lah, discussion. Right, so on the next tu nanti you boleh tengok video. Kalau I upload video, I akan go live lah. Right, so I assume if you dah download the slide, I assume you baca, then dalam that time tu, then you kena isi attendance lah. I open attendance for 2 hours. Okay, dengan kelas on Khamis ke Rabu ke, kalau I dah upload on Selasa tu you boleh apa ni lah, tapi attendance still on time punya time lah. Okay, saya tak buka you punya aspek tapi apa? Ada satu chapter sebelum livelihood tu, salah saya tak ingat lah. Ada satu chapter tu. Okay, yang that one I akan that's after finish last chapters lah, graduations tu. After that I will go back to the chapters before yang Asante supposed to release. Alright, if tak ada, I boleh end kita punya meeting lah. Okay. Assalamualaikum warahmatullahi wabarakatuh.
Thank you, madam.
Thank you, madam. Thank you, madam.